Okay, we are now continuing with our patterns in a table when we're given an input and an output. Okay, and just like in our number patterns and our sequencing patterns, we need to first decide, are these numbers getting larger in the output or are they getting smaller? So let's take a look at this example. Okay, our input is 100, our output is 90, so I know these numbers are getting smaller. If they're getting smaller, we have to either subtract or divide, right? Because in addition and multiplication, numbers get bigger and we need smaller numbers. So I always like to start with the easier one of subtracting. So I need to think, what do I need to do to 100? What do I subtract from 100 to get 90? I know 100 minus 10 equals 90. Okay, I need to try this out on at least one other to make sure it's the correct pattern. So I'm going to pick 80 and subtract 10. 80 minus 10 equals 70. So I know my pattern is to subtract 10. So now to finish my table, I need to subtract 10 from 60, which gives me 50, and subtract 10 from 50, which gives me 40. Okay, so your missing numbers in this pattern are 50 and 40. Now some of you might pick up on some other patterns in tables. It's not going to work out all the time, but sometimes it does. For example, this output goes down by tens. 90, 80, 70, 60, 50, 40. It might be a good way to check your answers. All right, let's try another one. Okay, in this table, okay, there are different numbers being left out. It's not the last two, okay? They have random ones. So we are going to do the same thing. Okay, I'm going to pick two and decide, okay, are these numbers getting larger or are they getting smaller? They are getting larger, which means it's going to be addition or multiplication. So I need to think, I always like to start with the easier one of addition. 4 plus what gives me 12? 4 plus what equals 16? I know 4 plus 12 equals 16. Okay, I need to try at least one other one to make sure this rule is correct. So let's see, 8 plus 12. If I do 8 plus 12, I'm going to get 20. But the output's 32. That tells me that this rule is incorrect, that we can't use this rule. It is not plus 12, which means it has to be multiplying. So now I need to think, 4 times what equals 16? Well, I know 4 times 4 equals 16. 4, 8, 12, 16. 4 times 4 equals 16. Again, just like before, I need to test this by doing it to one other one. Let's try 8 times 4. Okay, so I have 8, 16, 24, 32. Okay, and that is what I have. So I know my rule is to multiply by 4. So now I need to find my last two outputs. So I start with 2 times 4. 2 times 4 is 8. And I need to do 6 times 4. 6 times 4 is 24. Okay, I've got one more example for you. Okay, here's another input-output table. Okay, again, this time it gives us random ones missing and it's even missing an input. So we need to find one of our inputs and our missing outputs. All right, so I'm going to look at two that are given. So I have a 3 and a 1. Okay, so the numbers are getting smaller. They're putting in a 3. It's coming out as a 1. Okay, these numbers are getting smaller. I need to subtract or divide. I always like to start with the easier of the two. So I'm going to subtract. 3 minus what is going to give me 1? Well, I know 3 minus 2 equals 1. Always try it on another to make sure it's the correct pattern, because if it's wrong on a different one, then it's not the right pattern. So we're going to try 6 minus 2. 6 minus 2 is 4, but that's not what the output is. So this is the wrong rule. We need to try something else. Okay, so let's go back to 3 and 1. 3 divided by what equals 1? Well, I know 3 divided by 3 gives me 1, right? Anything divided by itself equals 1. So now I need to try it on another one. 6 divided by 3. So I'm going to skip count by 3s till I get to 6. 3, 6. I got 2. So 6 divided by 3 equals 2. Okay, and it should work for all the other ones. 15 divided by 3 equals 5. Okay, so now I need to fill in the blanks. 0 divided by 3 is always going to be 0. Okay, let's try 9 divided by 3. So I'm going to skip count by 3s till I get to 9. 3, 6, 9. So I know 9 divided by 3 equals 3. All right, now here's where it's tricky. Okay, this time I'm missing the input and the output is 4. So I need to think, what divided by 3 equals 4? Well, I need to think about my fact families. Okay, in order to find this number, instead I need to do 3 times 4, right? I'm given a 3 and I'm given a 4. So I'm going to try my fact family and know I can do 3 times 4 to find that missing number. 3, 6, 9, 12. 3 times 4 is 12. If 3 times 4 equals 12, and my missing number is what divided by 3 equals 4, well, my missing number is 12. Okay, so my missing numbers in this graph were 0, 3, and 12.